Number 6 on our chapter 7 test. These two problems, I saw a lot of different ways, and these were probably the two most difficult ones, and didn't intend them to be this nasty, but that they turned out that way. Okay, so there's uh, so many different ways to do this problem. You could do it by integration by parts, by substitution, by trig substitution. They all will work. I kind of intended you to do this one by just regular substitution. But the problem on this one is if you're putting 1 in, you're going to get 1 squared, which is 1 minus 1, 0 in the denominator. So this is one where you're going to do the limit as some letter, A, R, P, Q, whatever, some variable, goes to 1, the integral of A to 2 of 3x over x squared minus 1 dx. So that I expected to see right off the top, identifying the problem in this particular problem. This is the area of concern. So, however you integrate this, and I'm going to integrate this, the integral of 3x over x squared minus 1 dx by substitution, because I felt like that was the easiest, letting u be that, because du would be 2x and the x's would cancel, dx, so dx is du over 2x. So this becomes the integral of 3x over u du over 2x. The x's cancel. The 3 halves come out, and we have 3 halves, the integral of 1 over u, which is ln u, and then it would be plus c, but this is a definite integral. So this would become the limit as a approaches 1 of 3 halves ln, and u was x squared minus 1, evaluated from a to 2. Now, if I evaluate that from a to 2, I put the 2 in first, and I have the limit as a approaches 1 of 3 halves, put 2 in here, and I have ln of 4 minus 1, 3, minus, put the a in here, and I have ln of a squared minus 1. Now, ln of 3 times 3 halves is pretty straightforward. And when I take the limit as a goes to, that's not going to change. So this would be 3 halves ln 3 minus the limit as a approaches 1 of ln of a with a 3 halves. Oop, don't forget that. 3 halves ln of a squared minus 1. Now, as a goes to 1, a squared would be 1. 1 minus 1 is 0. ln of 0 goes to negative infinity. And so this diverges. It has no limit. So that's that one. That one was the easier of the two. And you have to do all this to show me that it diverges. You have to go through the whole setup and work the limit out, and the derivative out, excuse me, the integral out, and show this to get your 6 points. Now the second one, which was this. I'll slide this down here. Work that one. So that's the integral from 1 to infinity, which is the problem. So I'm going to put the limit as a goes to infinity, or r, or some variable, of x e to the, whoops, that's not the correct problem. What did I have? Where is these? That's a different problem than when I put on the test. I believe. Gotta check it. Yeah, that's a different problem. So get rid of that one. Everything up to there was the same. This is 2x plus 5 over e to the x dx. Okay, it's still, as a goes to infinity, that was still the problem. And the issue with this particular problem, 2x plus 5 over e to the x, 1 to infinity. Okay, so that's what we got to figure out here. Now, I've saw a lot of different methods used to solve this. But first of all, let's get this clear. This is the limit as a approaches infinity of the integral from 1 to a. And that e to the x, we cannot use L'Hopital's rule now because we're not taking the limit. It's we have an integral to take care of first. It's only when we're doing the limit, no integrals involved, that we use L'Hopital's rule. So we have to actually do this integration. And if we could do this as separate fractions, and that works pretty well. We can also use integration by parts. But if either case, we really want to do this as e to the negative x times 2x plus 5 dx. And if I do this by parts, which is what I kind of anticipated you would do, this would keep staying there. This is the part that would reduce to simpler constant. So that's what you should let u be. U be the 2x plus 5, so that du would equal 2dx. And let dv be the rest of this, e to the negative x dx. When I integrate this, I would get e to the negative x with a minus, because the derivative of that chain rule would produce a minus 1, and that would cancel the minus and make it plus. So this would become the limit, I'll write it here, as a approaches infinity of uv, a minus 2x plus 5 e to the minus x, which means over e to the x, minus the integral of v, which is minus e to the minus x du, which is 2 dx. Now we still need to integrate this. So this would become the limit as a approaches infinity, and we could do this part separate, but well, actually, let's go ahead and separate this out. So this would be the limit of negative of 2x plus 5 over e to the x, and a minus would make this plus, and I'm going to write it as plus ln limit lim limit of, as a approaches infinity, of 2 integral of e to the negative x dx. So I just split these up. Now this one I can do, I think. I can figure that out. And then I'll have to figure out what that comes out to be. Oh, and these are from 1 to a. And this is evaluated from 1 to a. So we got two things going on. We got to figure this one out and this one out. Now, if I put a in here, I'll have the limit as a goes to infinity of a in this, which would be minus 2a plus 5 over e to the x, e to the a, minus a minus, which would be plus, and put 1 in here, and that would be 2 times 1 plus 5 over e to the 1. That's this first part. And then I got to have plus the limit as a approaches infinity. The integral of e to the negative x is negative e to the negative x times a 2. And I got to evaluate that from 1 to a. So this is going to be putting a in there. I'm going to get, and I'll put that in the denominator, e to the negative x. So I'm going to have minus 2 over e to the a. That's going to be positive because I'm moving it down. That makes that negative exponent positive. Minus a minus, which is plus 2 over e to the 1. Okay. Now, this is just a constant, and the limit as a goes to infinity doesn't affect that. But this part right here, as a goes to infinity, this numerator goes to infinity, and the denominator would go to infinity. And when you have that situation, L'Hopital's rule applies. Now, there's no integral here. We're just taking the limit of two things that both go to infinity, which is when L'Hopital's rule applies. No integrals, just the limit of a fraction. So we can take the derivative of the numerator, which would be just minus 2. So for this part only, this limit of this here, it's going to be the limit as a goes to infinity of minus 2 over the derivative of e to the x would be, or e to the a, would be e to the a. All right, that's this part. The limit as a goes to infinity of this is already figured out. So this is on the limit's only on this. This is 2 plus, so it's 7 over e plus, as a goes to infinity, this part goes, this will go to 0, or go to infinity, and 2 over that would go to 0. And this has nothing, so this goes to 0, so that's okay. So we just get the limit of this is just 2 over e. And as a goes to infinity, this goes to 0. So using the L'Hopital's rule, we get that going to 0, and we get this, which is 9 over e. And it converges to that value, which is 3 point something. We're 6 points. Now, there was other ways to integrate this, but you end up with the same result. You still need to use L'Hopital's rule at some point in there. Okay,